Aloha everybody, this is Gigi from Kauai Community College. This is a video on graphing functions, specifically in a unit after the first and second derivative. So we're going to learn from what the first and second derivative would tell us about a graph so that we can sketch this function. Okay, and this function is f of x is equal to negative e to the negative x times sine x, negative exponent, so we can rewrite it as sine of x over e to the x. So when we are looking for the domain of this function, which is point number one, the domain of this function, the denominator is never zero because e to the x power looks like this. E to the x power is like this, right? That's the exponential function. So e to the x will never be zero. So we're always good. And then sine of x has all x values be in its domain. So no restrictions here for this function. However, the question said we are only graphing it in between the negative pi to pi. So that's what we mean by domain or interval of interest. The interval of interest in this case goes from negative pi to pi. Okay, I'm going to go ahead and divide up this into 4 sections. So we have pi over 4, pi over 2, and 3 pi over 4. Okay, there you go. All right, so we're just going to leave it as that. And then when we are looking at symmetry, okay, when we're looking at symmetry, we would say that it has no particular symmetry just because when you are looking at the f of negative x, that would be sine of negative x, and we know that sine of the opposite of x is the opposite of sine to x, divided by e to the negative x, which really give us negative e to the x sine x, which is neither the same or the opposite. So there's no symmetry to be had here. And the domain is still, as we said, from negative pi to pi, which is the interval of interest. Okay. Now, to find point number 3 is to find critical point or possible point of inflection. And so that would be first derivative and second derivative. Okay, so f of x is equal to sine x over e to the x. So first of all, we would say, let's go and find the first derivative. The first derivative is quotient rule will apply here, e to the x power, and then square on the denominator, right? That's how the quotient rule works. The derivative of the numerator, which would be cosine of x multiplied by e to the x, minus the derivative of e to the x is e to the x multiplied by sine of x, all divided by e to the x squared. And as we can see, everything has an e to the x, so we can say we're going to divide everything by e to the x to reduce this to be e to the x on the denominator, cosine of x on the numerator minus sine of x. Okay, so critical points would be critical point are when the derivative is 0 or when the derivative is undefined. Okay, so e to the x in this case is always positive, as we have said before when we were looking at the domain. So the only time that you would have a critical point would be when the derivative is 0, and in this case, derivative is 0 when cosine of x minus sine of x is equal to 0. So the question being here, looking at a unit circle, when is cosine of x the same as sine of x? so that when we subtract, we will have 0. It would be that point right there and this point right here. This point right here, we can call that pi over 4. This point down here in the third quadrant could either be 5 pi over 4, or when we go the opposite direction would be negative 3 pi over 4. And negative 3 pi over 4 would be within the negative pi to pi interval. Okay, so critical points in this case are, so our critical points are when x is equal to pi over 4 and x is negative 3 pi over 4, which we will do what? Put that on the number line and test it. Okay, so pi over negative 3 pi over 4 right here. And we know that the interval that we're looking at is from negative pi to pi. And then pi over 4 is somewhere right here. Okay, now when we say put it in on the number line and test it, what are we saying? What are we testing? We're testing to see if the derivative is negative or positive, meaning interval of increasing or and decreasing. Okay, so those, you put those critical points on a number line so that we can test to see when the function is increasing and when the function is decreasing. All right, so I am going to do some trigonometry here, some calculations here. So first, pick a number between negative pi and negative 3/4 pi. So I'm going to go ahead and say I'm going to pick this right here, this number right here. Okay, so as we can see, when x is right here, let's say negative 7 pi over 8, so, okay, cosine is a negative number that is bigger than sine, right, or longer than sine, really. Okay, so a negative number that is bigger minus a negative number that is smaller. Okay, so that would be a negative big plus a positive small, which is going to be a negative number. I don't necessarily have to know the value, but I just need to know like the length of it, the magnitude of it, right? So, so there we go. This right here is the first derivative is less than 0. So this function is decreasing in this interval. Okay, and then we would say, what's next? What's next is when x is in between negative 3/4 and positive pi over 3/4 pi, negative 3/4 pi, and pi over 4, between a negative and a positive. Let's just pick 0. So when x is 0, cosine of 0 is 1. And oh, I didn't pay attention to the denominator because I know the denominator will always be a positive number. So a negative right here, what I should have said was it was a positive negative divided by a positive, which is a negative, okay? Whereas here we would have, on the numerator, we have 1 minus 0 over a positive number, and that is 1 over a positive number is positive. Right? That is when x is 0, right? So we would have this right here, this function where the derivative is greater than 0. So it is increasing, okay? And then we look at a value between pi over 4 and pi. let's call it pi over 2, which is this point up here. Cosine is 0, so we would have 0 when x is pi over 2. What we have is 0 minus 1, all divided by a positive number, and that would be negative on the numerator divided by a positive. Negative divided by a positive is a negative. Okay, so this right here, this function right here, the derivative is less than 0, so the function is decreasing. Okay, so those are the interval of increasing and decreasing. We will go ahead and let's look back at our function here and label those. So right here at negative 3 over 4 pi, and then at pi over 4, those are your possible max, relative max and min. And actually we could find out which one is which. So right here, when the function is changing, the derivative is changing sign, decreasing, increasing, you have a relative minimum right there. And then here, increasing, decreasing, so you have a relative maximum right here. Okay, where is here? We're going to go ahead and figure that out in a little bit. We need the actual point on the graph. So let's just leave it right there for now. Okay, the next thing we're going to do is we are going to find the possible point of inflection and then check for concavity. So that would be the first derivative, as we have seen earlier, is the first derivative is cosine x minus sine x over e to the x. So then the second derivative is quotient rule will apply e to the x square on the denominator. The derivative of the top is derivative of cosine x is sine negative sine x. The derivative of sine x is cosine x, so minus cosine x multiplied by e to the x minus the derivative of e to the x is e to the x multiplied by cosine x minus sine x. Okay, so that is the quotient rule. To simplify, we would say, look, I can divide everything by e to the x, so that's e to the x is gone. Minus right here, minus cosine, distribute the negative end, plus sine. Okay, that's going to cancel with the negative sign in the front. So what you have left is negative x and another negative cosine x and another negative cosine x. That would be negative 2 cosine of x, all divided by e to the x. Again, your second derivative is not going to be undefined ever because the denominator is not going to be 0. So possible point of inflection would be when cosine of x is 0, when the numerator here is 0. Okay, so on a number line, we will go and look at when cosine of x is 0. Cosine of x is 0 right here at pi over 2, which is within the interval from negative pi to positive pi, or it is here, which we would call negative pi over 2. Okay, so on the number line, again, we will have right here negative pi. Right here at the other endpoint, we have pi because that's the interval that we are graphing it in. And then we would have negative pi over 2 and then pi over 2 right here. Okay, now if we were to really look at the interval and test, let's just do that. Let's do that here. I'm not going to combine that with the first derivative, the increasing, decreasing yet. We're going to put it together later, okay? So here we go. Let's pick a number between negative pi and negative half pi, meaning a number from negative pi to negative half pi, that will be between here and here, okay? And let's just pick, what do we want to pick? Right here, let's say pi, negative 3 pi over 4. Okay, that would be cosine of x would be square root of 2 over 2 multiplied by 2, and it's a negative number times a negative number is a positive number. So we would have positive divided by positive is a positive. So the second derivative right here is greater than 0, so it concave up. Okay, and then the pick a number between, so that would be this guy right here, okay, that guy right there, and then we'll pick a number in between negative pi over 2 and pi over 2, which would be within this interval right here. Let's pick 0. Cosine of 0 is 1. 1 times negative 2 is negative 2 divided by a positive number. The second derivative is negative. So this interval, your function is concaving down. Okay. And then for the third interval, we are looking at from pi over 2 to pi, which is this part right here. Let's pick this right here, which is 3 pi over 4. The cosine value is negative square root of 2 over 2 times 2. That's still a negative. Negative times a negative is a positive. Divided by a positive number, that would be a positive number. So second derivative is greater than 0 here. So this right here concave up. Okay, and then when we're looking at these things, we would say, look, there is this right here. That is where a point of inflection will happen, because that is when there is a change in concavity. And then right here, there is also a change in concavity. So a point of inflection will happen right there. Okay. And then the question is, we have all of these points. Let's put them together. Let's put them together. What do I mean by that? I'm going to go ahead and combine this information here, okay, and this chart here together and see what we get. And then we're going to put that on here. So what are the points that are missing on here? We're missing negative pi over 2, and then here positive pi over 2. Okay, so let's put the interval together. Actually, before we put the interval together, it would make sense to actually find out what the function values are so that I know where the points are on that graph. Okay, so we will find f of negative pi, f of negative 3 pi over 4, f of negative pi over 2, f of 0, because that's where your x-intercept is, and y-intercept also, and then f of 0 is 0 actually, and then f of pi over 4. These are the points on the graph. So we're looking at these particular points here, and then f of pi over 2, and then f of pi finally. Okay, so f of pi, sign is 0, so the function value, the function that we are looking at, f of x, is, remember, sine x over e to the x, right? So f of pi is 0, f of negative pi is also 0. Okay, and so f of negative 3 pi over 4, let's use our calculator for that, and we'll get roughly negative 7.46. Here, f of negative pi over 2, calculator will tell you that it is approximately negative 4.81. And then at pi over 4, the answer is approximately positive 0.322. And then this one right here is approximately 0.208. Okay, so these are the points that are on the graph. So let's go ahead and put them where they belong in our graph here. So in our graph, we would see the point negative pi 0, 0, 0, and pi 0. And then at negative 3 pi over 4, we are looking at negative 7 something. So let's go down here, and we will call that negative 7.46-ish right there. Okay, not to scale, of course. And then, you know what? Yeah, okay. I was just going to erase the y-axis, but go ahead and leave that there. And then pi over 4, that would be 0.3. I'm amplifying this here so it's not to scale, 0.322. Okay, and then at negative pi over 2, we will have negative 4 point something. So I'm going to say that right there. I'm going to call that negative 4.81. And then here we would have 0.2 something. So it's just a little bit less, 0.208. Okay, definitely not to scale, not to scale. But there is the function. Now, if you put the two charts together, we would see that your function is, first of all, decreasing, right? Decreasing from negative pi to 3 pi over 4. So that actually is decreasing and concave up in this interval. And then from negative 3 pi over 4 to negative pi, it is increasing, but it's still concave up. So it looks like this, increasing, concave up. Okay, and then it changes concavity at that point because we had said that that's the point of inflection. So, and then it's increasing, concave down. Let's make it smooth and nice. And then concave down and increasing, so it would be like this. Okay. And then it continued to increase and concave down up to here. And it is still concaving down, but decrease here up until pi over 2. It's still concaving down. And then from negative pi over 2 to pi, it's continued to decrease, but concave up. So it would be like this. Okay, so that is the graph for the function e to the the function f of x is e to the negative x sine x. Okay, and that is it. We go through these points, finding all of these things. First derivative will tell you when it's increasing, decreasing, and concavity, which will give you relative max min, and then also point of inflection. Okay, and then we don't need to worry about vertical asymptote, but we do, and we also don't need to look at the end behavior because we are only looking in this interval right there. Okay, and the x-intercept and y-intercept is almost obvious. When x is 0, y is 0, and so on. So that would be the intercept, right? And then plot the points if necessary. That's what we did here. We find out these values right there so we can plot the points, and then we will put them together and graph it. Okay, now to really answer this some question here, that's we have a couple of point of inflection, which would be here and here where the red are. So that's another point of inflection. And then where the blue are, we would have our relative max and min, relative minimum, and this is a relative maximum. But really, in a closed interval, what can we say? A function that is continuous on a closed interval will have an absolute max and an absolute min. Looking at these values, we can tell that this right here is our absolute minimum, and then that up there is our absolute maximum for that interval. And that is it. That's a really long video, and you honestly don't need to do many of these, but because it basically put everything you have learned together, right? So go through the screen and maybe screenshot these here. You're going to have to go through this one, which is your first derivative, right? And then do your increasing, decreasing interval, and then you'll take your second derivative and do your concavity. And then you will find out the value of at those points, and then you'll put those two charts together on a graph as far as the information go, right? And then you just sketch the graph, and that's just how things go. It does take a long time to put things together here.